Hey everyone, Andrig with Andrig's Aircooled technology. Just wanted to give a quick product update. Um, on the fan kits, people have been asking. They've been removed from my online store for now, and the reason for that is pretty straightforward. The original fans, 3D printed fans. This is actually the one I tested with and have continued to test with here, but have had a number of failures. So, variety of different kinds of failures. You can't really tell basically what's causing them to fail. Some are failing right away, some after a long time of use and they're failing only partially. Some seem to be fine. So, don't really know what's exactly going on. And because of that, I decided to just stop selling them. In regards to that, I got a plan for how to move forward. The technology works great, right? So from a standpoint of the actual cooling, all the customers who have given me data for what they have experienced with this dual inlet fan design have given me really good data. 30, 50 degree cylinder head temperature drops, anywhere from 6 to 11 degree oil temperature drops. If it was a new engine, I've had customers telling me it's like, oh, their oil temperature never goes above 190, and that's in South Florida in hot weather, humid hot weather. So, and decent sized engines with good performance, right? So, the technology works, right? So the airflow numbers and show that it works in terms of that. In practice on an actual car and engine, they work just fine, but I really can't afford and really don't want to sell something that just might fail randomly for reasons unknown. So with that in mind, I paused this. Now, I am coming up with a solution for this, and I've been working really hard on it. Obviously, this is was my best-selling product, so so without it, I'm not selling a whole lot, and that's pretty painful from a business perspective. So I've got a plan, and so and I did today some work on that plan. I got some prototype parts, and I'm going to show you just part of this. This is it's going to look pretty crappy in terms of it's a steel kind of version of the fan. It's like all cut up and everything, but I tested some ideas with these prototype parts that you can see here. The fan center is the same as the 3D printed part, so that's what I want to maintain that, and all the other parts, mounting parts, would be exactly the same, dimensions would be exactly the same. So you could take this fan and put it in place of the 3D printed part. So if you had an exploded fan, if you keep your mounting parts, please. And when I come up with this, hopefully soon, you'll be able to get this in place of that and just mount it with the same mounting hardware you already had. So, I attempted to weld this centerpiece in because this has to be CNC machined. This is just, a sheet metal. And of course it causes it to kind of potato chip, right? So that's about the best I could do in terms of, and you can kind of see how it's pretty wonky. That doesn't make a good fan, right? Because it's not going to spin true. So, but that was an experiment, part of experimenting with how to assemble this stuff and everything. So I had done different welding settings, etc. This one actually didn't potato chip as much as that one did, and it was pretty close, but it's still with the lowest possible settings, and I still was getting good penetration, so that weld was good. It's still, I can't keep it from warping and staying straight. So with that in mind, I have to change tacks. But what I did get accomplished today is this is just one side of the dual-sided fan. The blades would be on the other side as well. With this ring, etc. It's just making sure it assembles correctly, right? And it's not hard to assemble, and the parts fit decently and tightly without being, and that that proved today. That came out perfect. So we're going to change tack on how we do the center for the mounting, but the rest of this looks really good, and it's going to end up being a hybrid part. Excuse me, I'm going to show you one other piece. And so one of the things about, people have asked me about doing steel in the past, and one of the really hard parts is this. So this aspect of the fan, it's kind of it ends up being like a velocity stack, right? Part of the fan. That's really hard to make out of steel. The tooling cost is very expensive. Plus, this geometry is different than OEM, and it's different in such a way that actually makes it even more difficult to make steel like in a stamping kind of operation. And you can't get good prices and amortize your tooling cost or whatever unless you're making, hundreds of thousands of these things, right? Which I'm probably never going to make hundreds of thousands. Well, you never know. Hundreds of thousands of these things. So what I did is I took this design 3D printed, and I 3D printed it in such a way that I can bond it to the steel. This is a non-structural, so all the structural pieces will be steel. The non-structural part, and this has some things that will be modified on it, so that sits flat and it gets bonded to this. We'll be able to take the temperatures, epoxy bonding, be able to take the temperatures and everything, so it won't be, and it won't be any real structural stress. And in fact, this aspect of this, like I could, on this, I'd put it down here, but on the fully 3D printed fan, I could stand on that fan, right? I could actually put my foot across this and stand on it, and it wouldn't cause it any heartburn. So this is plenty strong once it's bonded to the steel structure. So this is going to end up being a hybrid. If this works, and of course I got to test the bonding and the bonding strength, that kind of stuff. But based on everything I've read in the specs for the bonding, materials I'm buying. In fact, I got some more coming. This thing should just be rock solid. It shouldn't really be a problem. So that's kind of the plan right now. I've got more prototype parts coming. Obviously, I ruined these, so I got more parts coming. They should arrive next week, and I can fully assemble this, the full fan, attempt to do the bonding of the 3D printed parts, and test it out and see. So hopefully in the next few weeks, I'll have actual prototypes that are working, that I know are strong, and it will be pretty lightweight for a steel fan, especially double-sided and as large as it's going to be. I don't really know exactly how much it's going to weigh compared to the OEM fan, but I am using thinner materials for the blades than what the stock one uses. For the most part, it seems thinner anyway. So it might be, I think it's going to end up being lighter. We'll see, and there might be some more design changes I make to try to make it even lighter. We'll try to make it lighter than the OEM fan if we can. So we still have some of the weight benefits, and of course, the lighter you can make it, the less stress these parts are under in terms of wanting to fly apart, right? So, but I think this is going to turn out really good. This part turned out to be super simple to actually do the assembly of. So I was really happy with that, because that's one of the things in terms of cost. We don't want the assembly time to be many hours. It takes me usually around 4 hours to make a fan shroud. And if it takes 4 or 5 or 8 hours to make every fan, that's pretty tough to get any volume out, right? So that's the other thing we're trying to accomplish with this. And of course, the bonding the structural adhesives that are available today are beyond what a lot of car bodies are put together with structural adhesives these days instead of being welded, right? So I think this is going to work, and I think it's going to work really well. You just have to have the right bonding materials, especially across dissimilar materials. You got steel and a thermoplastic carbon fiber piece that has to go to it. As long as that bond works the way it's supposed to, then I'll probably test it in the oven. I'll test it on the test engine. I'll test it on my test stand in terms of airflow. I'll do all that testing. But I'm pretty sure, I'm pretty confident right now that structural adhesive will work really well in this application, making a hybrid 3D printed part. So 3D printed in steel part. So with the assembly being fairly easy, and of course, with the weight of this being the 3D printed part, and of course the backside will be the same. I can show you that. See, the backside will be the same. So it's just really small little velocity stack. That's where the backing plate inlet part is. So that has a really small one. Those things are so paper light that it's amazing. So generally speaking, I think because those big aspects are going to be so lightweight that I think the overall fan will be lighter. So that's the good news. And anyway, so I want to make that adjustment because people are asking lots of questions, and so I wanted to let you guys know what's going on, what's happening, and the fact I'm just not comfortable selling a product that might randomly fail, right? You don't need to be driving your car, and away from the house where all of a sudden your fan fails, right? And you got no cooling system. So we don't need that. I want to sell these things and know that they're just going to survive. And even in this particular case, even if the 3D printed part or whatever fails, you're still going to have a working fan. So if it failed for some reason, then the fan, the steel parts are together, you're good, right? So that's another benefit of kind of going down this approach. You get the airflow benefits and we get some of the lightweight benefits of the 3D printing, but we do it in a non-structural way. And even though this stuff is pretty thin, after I assembled it, even though I cut out the center and there's this is flex, this thing doesn't flex at all. So I think we're in really good shape with this, and but it's going to take a little bit of time to get this through prototyping and testing, making sure the adhesive works the way I expect it to work, and I can take the heat, because the adhesive that I'm going with too on this should even be able to withstand like powder coating temperatures, like 450 degree Fahrenheit without issue, maybe even over 500 degrees Fahrenheit. I have to look at the some of the specs are a little vague, so I'll have to do a little more research. But right now it looks like temperature certainly not going to be an issue. Very high temperature resistance, chemical resistant shouldn't be an issue as well. So I think this is going to work. So I'm excited about getting this going for you guys, and I hope there aren't more failures out there. And if you've had a failure, know that this is coming, and I'm going to run a special for anyone who's had a failure. In terms of when I get this introduced, so that you guys can get it, fairly cheaply. I mean, obviously can't give these away for free, and I can't give away, replacement 3D print fans away for free all the time. I'd go out of business. So we're just trying to stay afloat, but I'll do the best I can by anyone that's had a failure. So I appreciate the time, and look for this. I'll post some more updates on this as I go through the testing process, and I get the parts next week, and we will additional parts next week, more assembly testing, and I'll have I have 2 different adhesives to try, and I might use both. One for the 3D printed part, one for the steel. We'll see. But that looks like the way this is going to go. And I think it's going to work. I really do. And of course, if it doesn't work, I'm not really sure what I'll do. But because welding these things together, there's a reason that Volkswagen used kind of a pinch assembly technique with this stuff. Welding the stuff together is going to cause them to warp, right? So they did a kind of pinch assembly thing. They basically have these like pins coming through, but what they did is they have a big press machine that actually splits those and widens them out and pinches it together. And when you get a quote unquote welded fan, all they've really done is put a tack weld on top of one of those. To help keep it together, right? So, and of course, if that's all you're doing on a fairly thick piece of metal, you light heat, And they really only, like, these have 2 pins, and the OEM fans have 2 pins too. They're further apart. When you do that, and that metal is actually thicker, they only do it on 1 pin. 1 pin, 1 pin, 1 pin around. You can keep the heat, low enough that it's not going to warp the fan. So we're gonna go that direction, and hopefully we'll end up with a great fan. But the design is exactly the same as the 3D printed part. So airflow wise, it'll be great, just like the 3D printed part was, and the cooling will work. Of course, because most of it will be steel. It will need to be painted. I'm probably gonna paint this structure, minus the bonding surfaces for the 3D printed parts, just so that it comes painted for you already. You could always paint it a different color or whatever if you wanted, but just so that it doesn't rust on you. And so that's going to be another aspect of kind of the assembly process, is painting these things, and hopefully I can do that pretty quickly. I think I've got the right stuff to do that fairly quickly. So that's where we are. Appreciate the time, and I'm gonna put that down, and I'll keep you updated as I go forward. Thank you. Bye bye.